in this circumstance, May and Andre found that old genie bottle, and this genie came out, and instead of granting them wishes, gave them each a magic coin. And this magic coin was magic. I don't know if you could tell by its name being magic coin. And this magic coin would double every day. So 2 coins on the first day, 4 coins on the second day, 8 coins on the next day. And you know how you know where this coin was from? It was from Ireland. You know how you know?
Because Islanders coins.
No, because it was Dublin. Anyway, you want to learn more about the genies other than this math we're checking out, you can watch the documentary on Disney Plus, Aladdin. So what we need to do here is figure out how many coins there are on the 28th day as an expression, okay? And I want you to find out, Andre had a defective coin. Maybe he had the budget genie, I don't know. But his stopped doubling on the 25th day. So I want you to tell me how much more May has than Andre. I'm going to give you about 8 minutes at your table group for this. All right, y'all, let's talk about these coins. Who found a good way to express the amount of coins May had on the 28th day? Who found a good way to express that? Lily? Yeah, 2 to the 28th is what that is looking for. So 2 to the 28th power. That means times 2 times 2 times 2. Now, did anybody choose to write? Times 2 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 times 2? No. Good. 2 to the 28th is the efficient way to do that. All right. Now, Andre's coin. Who's got how many more coins she has than Andre? May has 25 versus 28 days, right?
Enough time.
Yeah. 3 times, okay. So Ivy's saying 3 times because there's 3 less days, right? But what's happened each one of those 3 days?
Doubling. It's 3.
It's doubling each of the 3 days difference. So I'm hearing some 6s out there.
6 times.
What else, Zeph? What are you thinking?
8 times. Yeah.
8 times.
2 times 2 times 2.
Oh, double would be 2 times 2 is 4 times 2 is 8. I think there's a way to math this to figure out who it's right. By the way, if you're saying some of these answers I'm pointing out, that is anticipated, okay? And what we're doing with that is not being like, someone got it right, someone got it wrong. If you throw out a wrong answer, your brain has an opportunity to grow. So let's see what's right, what's wrong. Let's justify it. So I like to think of it as like this, that Andre has 2 to the 25th. 2 to the 25th coins. And I saw some people with calculators out, and I'm guessing this is one thing that might have happened. I'm guessing there might have been a 2 to the 28th divided by 2 to the 25th. Anybody do that?
No.
To see how many times more?
Well, you could do that.
You could do that.
That's what I was thinking.
Okay, so I'm not doing this yet, but does anybody see how this would get her done? So I myself saw that there's 3 extra days of doubling. 2 times 2 times 2, or 2 to the 3rd. But let me show you how we can justify this with math to get 2 to the 3rd. Would you guys agree with me that this is the same thing as doing this? 2 to the 25th times 2 cubed over 2 to the 25th? 2 to the 25th times 2 cubed has 28 factors of 2 still, right? Now, the reason I'm choosing to do this is real simple. What is 2 divided by 2? 2 divided by 2 is always 1. So all these 2 times 2s in the numerator, 28 of them, how many of those would cancel with 2 times 2 in the denominator? I've got 25 2 times 2 in the denominator, and 28 in the numerator. How many of these would cancel each other if 2 divided by 2 is just 1? No, just hold on. Again, let me restate that. You guys know that the numerator and denominator are just a bunch of 2 times 2s.
Correct.
Any 2 divided by 2 is 1. So, 25 of these 2 times 2s would cancel out how many of these 2 times 2s? 25 of them. Which means I would be left with the difference of 3 2 times 2s.
So it's 8.
Yeah, I'm just justifying some of our answers of 8 using some mathematics. right? Can you guys see that 25 of the denominator would cancel 25 in the numerator? Because anything divided by itself is 1. And there'd be 25 2 times 2's in both the numerator and denominator. Okay? That's cool. So 8 times more. That seems like a lot more, by the way. Just 3 days, there's 8 times more. That's a lot. So, here's the deal. After a while, Jada picks up a new coin. But this coin is janky. She finds out on day 2, half of it's gone. Day 3, she's left with a quarter. Then, 3rd day, she's left with an 1/8. Her coin is broken. I don't know if they have a name for this broken coin yet, but I'm going to call it Doja coin. So, it's broken. And I want you to find out the fraction she has left after 6 days. I want you to say a fraction she has after 28 days. And I want to know, will this coin disappear completely? Do this at your table groups. I'm going to give you 5 minutes. Who can tell me what fraction they got after 6 days and how? Josiah?
164.
How'd you get to 164th?
I put down a table because I just did in my time one half of the math amount.
Oh, so you just kept, okay, so use the table. I like that. Let me show you what I did. It's similar to your table. I said I have 1/2 to the 6th power. And I knew that the 2 to the 6th power is 2, 4, 8, 16, 32, 64. Now, if I want to put half, because I'm having the thing over and over, the reason I put 1/2 in parentheses is, if I write it like this, oops, that looks like just the 1 to the 6th power, not the 1/2 to the 6th power. And the order of operations here would give me 1/2 instead of 1/64. But I also got 1/64. 28 days, how could we get that as an expression? Thinking about this, keep this in mind. Ivy?
Well, I actually had a different expression.
Okay.
I don't know if it's right, but 1/2 times 1 over d. Like d would just be the denominator, like whatever that is.
So the only thing with that is that it could be a lot of different things instead of just having. We need the having to happen over and over specifically. So another thing that I've seen today that I liked, a couple more, not that I liked or disliked, that I saw that was the same value. I did see something like this, 1/2 to the 6th like that. And I saw someone else do something like 1 times 1/2 to the 6th today. All these would be equivalent for the 6th. Now, what about 28 days? Keeping this right here in mind, how could I get an expression for 28 days? Troy, what do you think? In 28 days, how many times am I cutting it in half?
A lot. 28.
So I can multiply by 1/2 how many times?
28.
20, okay. So 1/2 to the 20th power. That's how I would write an expression for cutting this coin in half 28 different times. It'd give you a pretty little number if you did it, too, in your calculator, right? Mm-hmm. Anybody use the decimal instead of the fraction? 0.5? Because you could have. Next question. Does it ever disappear completely? What do you think? Does it disappear, Sean?
You can get it down very small, but it will never disappear.
It'll never disappear. This coin is forever. Now you might be like, listen, it's still only an atom. I don't know. It might be some magic matter we don't even know about because there's this genie, right? But let's say it got down to an atom. You split that atom, man. We got some neutrons and protons. I'm not sure what happens to electrons because electrons kind of like aren't stuff. It's more like energy. But then what happens when you're splitting protons and neutrons? I think you get things called quarks. I've about maxed out my science education in here except for what I know from Ant-Man. So, again, theoretically, smaller and smaller forever. I had some kid earlier today said, well, my calculator said 0 at like 30-something. Well, your calculator has a finite number of digits on the screen is the only reason that stopped, right? So, kind of no. Is what I'll write. Maybe get so small it fall right through your hand. The atoms that separate the things in your hand just fall right through all the gap. Woo!
Where'd it go with that?
To the core of the earth? I don't know. Thanos just be somewhere else and catch it. Because it wouldn't go through his hand. I don't know.